Welcome to Thought Frontier.
Hey everyone, and welcome back. Today we're going to be tackling a question that's, well, kind of been bugging humanity for a while now.
Oh, yeah?
Yeah, it's a big one. It's the Fermi Paradox.
Ah, the Fermi
Or
Paradox.
a classic indeed. And for good reason. I mean, it's the whole question of why, considering how absolutely massive the universe is and how old it is. We haven't bumped into any alien civilizations yet.
Right. You'd think with all those stars and planets out there, someone else would have shown up by now.
Exactly. So, for this deep dive, we're going to be digging into some fascinating sources. We've got scientific papers, expert opinions, and even some thought-provoking YouTube insights to try and make sense of this whole thing.
That sounds like a good mix.
It is. And while this topic can get pretty speculative, our goal today is to stick to the hard science, the testable predictions that are driving the current thinking on this enduring mystery. So, no wild conspiracy theories, just solid evidence and logical reasoning.
Sounds good to me.
Great. So to kick things off, let's define what we mean by the Fermi Paradox. It's not just about, like, little green men never visiting Earth, right?
Right. It goes way deeper than that. It actually all started with a simple question posed by physicist Enrico Fermi back in 1950.
Oh, yeah.
Yeah, during a casual lunchtime chat, he famously asked, "Where is everybody?"
Lunchtime chat, huh? Seems like a lot of great ideas start that way.
Absolutely. But Fermi's question was deeply rooted in the vastness of the universe and the immense stretches of time involved. His point was that even if a civilization had just moderately advanced spacefaring technology, they could theoretically colonize the entire galaxy in a few tens of millions of years.
And that's practically nothing compared to the age of the universe.
Exactly. So statistically speaking, even if just one alien civilization out there had embarked on a colonization spree, they should have reached us by now. The fact that we haven't encountered any such evidence is the heart of the Fermi Paradox.
So it's not just about aliens not visiting Earth, it's about the lack of any detectable evidence of their existence anywhere.
Precisely. The absence of alien settlements in our solar system. No strange signals or energy emissions. No signs of megastructures like Dyson spheres. It all contributes to this intriguing silence.
A real head-scratcher, for sure.
Now, to be precise, there are two ways to frame the paradox. The direct version focuses on the lack of visitation, and the indirect version focuses on the lack of any detectable evidence of alien activity, regardless of their physical presence here.
Okay, so we've established the paradox, but how have scientists tried to explain this cosmic silence? I know one early attempt was the Drake equation, right?
Ah, yes, the Drake equation, formulated by astronomer Frank Drake in 1961. It was a groundbreaking attempt to estimate the number of detectable civilizations in our galaxy.
And how does it do that?
Well, it considers factors like the rate of star formation, the fraction of stars with planets, the number of those planets that could support life, and so on.
It's pretty comprehensive.
It is, but, well, many of the variables in the Drake equation are incredibly uncertain. We're still figuring out things like the percentage of planets that develop intelligent life, and even more complex things like the average lifespan of a civilization.
So it's a useful thought experiment, but it doesn't give us concrete answers.
Exactly. It actually highlights just how much we still don't know.
So if the Drake equation doesn't solve the paradox, what are some of the leading explanations that scientists have proposed?
Well, one idea that's gained traction is the Great Filter hypothesis. It suggests that there may be incredibly challenging evolutionary hurdles, like abiogenesis, the development of intelligence, or even achieving interstellar travel, that significantly reduce the number of civilizations that reach a point where they could make contact.
Essentially, most civilizations might get wiped out or hit a dead end before reaching those milestones.
It's a possibility, and a rather sobering one. Another prominent explanation is the rare Earth hypothesis.
Oh, yeah, I've heard of that one.
This one suggests that the unique combination of conditions that allowed complex life to flourish on Earth might be incredibly rare in the universe.
So our planet might be a cosmic anomaly, just a lucky break.
Perhaps. Earth's stable orbit, magnetic field, plate tectonics, liquid water, the right kind of star. All these factors might be far less common than we initially assumed, making the emergence of complex life a highly improbable event.
That's a humbling thought. What other explanations should we consider?
Certainly. One chilling possibility is that civilizations might have a tendency to self-destruct once they reach a certain level of technological advancement.
Yikes. Like, what are we talking about here?
Think nuclear war, unchecked climate change, or even artificial intelligence turning against its creators.
Yeah, those scenarios don't seem so far-fetched considering some of the challenges we're facing here on Earth. It makes you wonder if there's some sort of built-in expiration date for intelligent civilizations.
It's a sobering thought, for sure.
Yeah.
And then there are even more speculative ideas,
Oh, like what?
like the dark forest hypothesis. It suggests that advanced civilizations might be deliberately hiding their presence out of fear of being discovered by hostile others.
So the universe is a dangerous place, and it's best to stay quiet, like a galactic game of hide and seek.
Precisely. But even beyond these more speculative ideas, we have to acknowledge the sheer logistical challenges of interstellar contact.
Right, even with highly advanced technology, the time and resources required to travel between stars would be enormous.
Exactly. Not to mention, even if other civilizations are out there, they might exist on different timelines. Civilizations could be rising and falling throughout the universe's history, meaning we might simply be looking for signals at the wrong time.
So we could be looking for a needle in a haystack, and the needle isn't even there at the same time we are.
Precisely. And of course, we can't overlook the limitations of our own search efforts. We've only been actively searching for extraterrestrial intelligence for a relatively short period, using technology that's constantly evolving.
It's like searching for a specific grain of sand on a beach with a magnifying glass. We're still in the very early stages of this cosmic exploration.
Exactly. And that brings us to some fascinating recent research that's adding a new layer to this whole discussion. Researchers at Oxford University's Future of Humanity Institute have been examining the timing of key evolutionary transitions on Earth to understand the probability of intelligent life emerging elsewhere.
Wait, so how can studying Earth's history tell us about the likelihood of life on other planets?
Well, they use something called the Bayesian model, which is a way to update probabilities as you gain new information. They looked at the timing of major events in Earth's history, abiogenesis, the emergence of eukaryotic life, the development of sexual reproduction, and of course the evolution of intelligence. They then analyzed those timelines within the context of Earth's habitable lifetime.
So are they saying that if it took billions of years for these things to happen on Earth, it stands to reason that it would take a similarly long time on other planets?
You got it. And here's where it gets really interesting. Their findings suggest that, statistically speaking, intelligent life, as we understand it, is likely incredibly rare.
So we might be even more alone than we thought.
It's a possibility, and one with profound implications. Now, there is another perspective called the self-indication assumption, SIA, that challenges these findings. But it gets a bit complex, and for now, we'll focus on the Oxford research and its implications.
Sounds good. But if intelligent life is this rare, doesn't that raise even bigger questions about our place in the universe? What does it mean for our understanding of ourselves if we're potentially the only intelligent life out there?
Absolutely. It challenges our assumptions and prompts us to rethink our approach to the search for extraterrestrial life. If finding another civilization is going to be this difficult, maybe we need to shift our focus. Instead of waiting for a signal, maybe we should be looking for something else entirely.
Like, what else could we possibly look for if we're not focusing on communication signals?
Well, instead of hoping to catch ET phoning home, we could look for the footprints they've left behind, unintentional signs of their technology. We call these technosignatures.
Okay, now you've got my attention. Tell me more about these technosignatures. What are we talking about exactly?
Think about the impact our own civilization has had on Earth. We've altered the atmosphere, built massive structures, and generate huge amounts of energy. All these activities leave traces. If an alien civilization has developed along similar lines, we might be able to detect those same kinds of traces on other planets.
So we'd be looking for things like pollution, artificial light sources, or even large-scale structures built around stars, like Dyson spheres.
Exactly. It's a more passive approach, but it might be more effective given the challenges we've discussed. And the Oxford research, with its suggestion that intelligent life is exceptionally rare, actually strengthens the case for this approach. If civilizations are few and far between, catching a random radio signal becomes even less likely. But if they've been around for a long time, the evidence of their technology might be more widespread and easier to detect.
That makes a lot of sense. So it's less about hoping they're trying to talk to us and more about being a cosmic detective looking for clues.
Precisely. And this change in thinking leads to some exciting possibilities, like expanding our search beyond our own galaxy.
Wait, are we talking about looking for alien technology in other galaxies? That seems incredibly ambitious. How could we possibly detect anything that far away?
It is ambitious, but the potential payoff is huge. It would allow us to overcome some of the inherent biases in our current search efforts, which are largely focused on finding life that resembles our own on Earth-like planets.
So it's like trying to understand the diversity of human cultures by only studying one small town. To get a truly representative sample, you need to look further afield.
Exactly. Extragalactic searches could reveal entirely new pathways for the development of civilizations and technologies. It's like adding a whole new dimension to our understanding of life in the universe.
Yeah. This is really expanding my perspective on the whole search for extraterrestrial intelligence. It's not just about listening for signals anymore. It's about understanding the vastness and diversity of the universe and looking for any clues that might point to the existence of other intelligent beings.
You're getting it. And there's another aspect to this that we need to consider. Our own understanding of life itself.
You mean, are we even looking for the right things? What if alien life is so different from our own that we wouldn't even recognize it?
That's a crucial point. We tend to base our search strategies on what we know about life on Earth. But what if life elsewhere has evolved in radically different ways? What if it's based on silicon instead of carbon? Or thrives in environments we would consider toxic?
Or what if it's a form of intelligence that doesn't even use technology as we understand it?
Exactly. We need to break free from our Earth-centric biases and consider all possibilities.
So it's not just about developing better technology for detecting alien life, it's also about expanding our understanding of what life could be. It's about opening our minds to the truly alien.
Precisely. And that requires us to delve deeper into fields like astrobiology and exobiology, to push the boundaries of our knowledge about the origins and possibilities of life.
This is fascinating. It sounds like the search for extraterrestrial intelligence is ultimately a journey of self-discovery, a quest to understand not just what's out there, but also who we are and what it means to be alive.
It's a profound and humbling journey, and one that, regardless of whether we find aliens or not, will undoubtedly enrich our understanding of the universe and our place within it.
Well said. This has been a fantastic start to our deep dive into the Fermi Paradox. We've covered a lot of ground, from the origins of the paradox to the latest scientific thinking, and even some of the philosophical implications.
We've explored the challenges, the potential solutions, and the profound questions that this paradox raises about our place in the grand scheme of things.
And I have a feeling this is just the tip of the iceberg. There's still so much to discuss, from the specifics of searching for technosignatures to the ethical and philosophical considerations of actually encountering another intelligent species.
Those are definitely conversations worth having. And that's precisely where we'll pick up in the next part of our deep dive.
I can't wait. Stay tuned, everyone. The adventure continues. Okay, so we're back, and I'm ready to dig deeper into those implications of the research we talked about last time.
Yeah, that Future of Humanity Institute study was really something, wasn't it?
It was. I mean, the idea that intelligent life might be super rare, it just kind of blows my mind.
It's definitely a big idea. And the thing is, it's not just theoretical pondering. That model leads to some pretty specific testable predictions.
Oh, yeah. Like what?
Well, for one, it has some interesting implications for M-Dwarf stars. You know, those small, dim stars.
Yeah, I've heard they're supposed to be good candidates for hosting habitable planets because they live for so long.
Right. The thinking is that longer lifespan equals more time for life to evolve. But here's the catch. If intelligent life, like life that requires a series of those big evolutionary steps we see here on Earth, if that's really rare, then it follows that M-Dwarf stars might not be so great for complex life after all.
Hold on, I'm a little lost here. Why not? I thought the long lifespan was a good thing.
It is, in theory. But the math just doesn't add up. If those evolutionary transitions are super tough to get through and they take billions of years, then even a trillion-year lifespan might not be enough time.
So even with all that time, complex life still might not evolve around an M-Dwarf.
Exactly. Which means that if intelligent life is that rare, and we don't find it around M-Dwarf stars, that would actually be evidence supporting this model.
Wow, okay, I'm starting to see where you're going with this. So we're not just looking for aliens, we're also using them, or the lack of them, to test our theories about how life evolves in the first place.
Exactly. It's like a two-way street. And it gets even more interesting when you consider another prediction from this model, the early emergence of life.
Meaning life popping up quickly after a planet forms.
You got it. And that has some big implications, too. For one, it makes it more likely that life might have originated somewhere other than Earth.
Whoa, are you talking about, like, Mars?
Potentially. If life started quickly on Mars, it could have even been transferred to Earth through those early meteor impacts.
So we might all be Martians originally. That's pretty wild.
That's a cool thought. And early emergence also supports the idea of a common ancestor for all life in the universe.
Like all life everywhere comes from that same first spark, somewhere out there.
Precisely. It kind of paints this picture of life spreading through the cosmos, rather than a bunch of isolated origins.
I like that. Makes us all part of one big cosmic family.
Right. Okay, now, one last prediction that I find is really interesting relates to some of those unsolved mysteries in biology.
Ooh, mysteries. I love a good mystery. What kind of mysteries are we talking about?
Well, one of the biggest head scratchers is how eukaryotes, cells with complex internal structures, how they evolve from simpler prokaryotic cells.
Yeah, that seems like a huge jump in complexity.
It is. And scientists still don't fully understand how it happened.
So how does this model fit in?
It suggests that some of these biological paradoxes might only be solved if we factor in those super rare chance events.
Like it was just a fluke, a 1 in a billion occurrence that led to us.
Exactly. It challenges the idea that these major evolutionary transitions are simple or inevitable.
Okay, so if this model is right, we're back to feeling pretty special again, but also a little vulnerable, knowing how unlikely it all was.
That's the thing about science. It often leads to more questions than answers. But these predictions are just the beginning. As we learn more about astrobiology and planets, this model could lead to a ton of new testable hypotheses, and maybe even change how we search for life altogether.
It's mind-blowing, really. I'm starting to think that maybe we need to find aliens not just for the wow factor, but because what we learned from them, or even the lack of them, could totally change how we see ourselves and our place in the universe.
I couldn't agree more. It's all connected.
Okay, so let's get down to strategy. Knowing all this, where do we go from here? How do we test these predictions and maybe, just maybe, crack this Fermi paradox wide open?
Well, if we accept that finding alien technology might be more realistic than waiting for a signal, then we need to figure out what that tech would look like and how to find it.
Easier said than done, right? I mean, how do you tell the difference between an alien artifact and just some weird natural phenomenon?
It's definitely a challenge. But remember that bathtub analogy. Scooping up a tiny bit of ocean water and hoping to find a fish.
Yeah, it's like we've barely dipped our toes into the cosmic ocean.
Right, so one way to up our chances is to cast a wider net.
Okay, I'm liking this. More tools, more data. Are you thinking bigger telescopes, better sensors, that kind of thing?
Absolutely. And not just telescopes. We need to think outside the box, like using machine learning to sift through all that data and look for patterns that might point to artificial stuff.
Oh yeah, let the algorithms do the work.
Exactly. They can handle way more data than we ever could and maybe spot things we'd miss.
Makes sense. So what else can we do?
Well, we need to get creative with the kinds of technosignatures we're looking for, too.
Like, what are we talking about here? Give me some examples.
Think about the stuff our civilization has done. We changed the Earth's atmosphere, built huge structures, used massive amounts of energy. All that leaves traces. So we look for those same traces on other planets.
So like their version of smog, or evidence of giant space stations.
Exactly. We're basically doing cosmic forensics.
I love that. So any specific missions or projects happening that are looking for these technosignatures?
There are, and they're getting more advanced all the time. Take the James Webb Space Telescope. It can study the atmospheres of other planets in super detail.
That's the one that sent back those incredible images, right?
That's the one. Now, its main mission isn't technosignatures, but it could definitely spot those chemical traces if they're out there.
So it's all about being ready for the unexpected.
Exactly. Then there are projects like Breakthrough Listen, which is specifically designed to find alien tech using some of the most powerful radio telescopes we have.
Right, they're scanning tons of stars for any hints of artificial signals.
Exactly. And then there are more ambitious long-term projects, like sending probes to nearby stars, which could get a much closer look at planets and maybe find those more subtle signs of tech.
Like those tiny spacecraft they're developing for breakthrough starshot.
Precisely. That technology is still in its early stages. But if it works, it could open up amazing possibilities for exploring other star systems.
It's exciting to think about all the possibilities. It sounds like we're moving into a whole new era of searching for alien intelligence. Less about waiting for a call, more about uncovering the clues hidden in the universe itself.
I agree. It's a necessary shift. We haven't found those signals yet.
Yeah.
And our technology is rapidly advancing, which opens up all these new possibilities.
And maybe, just maybe, this new approach will help us finally answer the question, are we alone?
Or, even more intriguing, if we're not alone. What does that mean for how we understand life, intelligence, and our place in the grand scheme of things?
Those are questions I definitely want to explore further. And speaking of exploring further, there's one more area of technosignature searches we haven't touched on yet, one that really takes us out there.
You're thinking extragalactic.
Extragalactic SETI, yeah. Looking for alien tech in other galaxies.
A bold idea for sure. But, as we discussed, it offers a way to get beyond some of the limitations of searching only in our own galaxy.
I've always been a fan of thinking big. But seriously, searching other galaxies? That seems like a massive undertaking. I mean, these galaxies are millions, even billions of light years away.
You're right, it is a huge challenge. The signals would be incredibly faint, and we'd need unbelievably sensitive instruments to have any chance of detecting them. But the potential rewards are immense. It would let us look at a huge and diverse sample of galaxies.
Okay, I get that looking at more galaxies gives us more data points, but why is that so important?
Well, imagine if you spent your whole life in one city. You might assume all cities are pretty much the same. But if you traveled to cities all over the world, you'd see a huge diversity of cultures, ways of life, architecture.
I see your point. So looking at other galaxies could show us totally new ways that galaxies evolve and maybe even how civilizations develop that we wouldn't see just looking in the Milky Way.
Exactly. It's like adding a whole new dimension to our understanding of the universe.
So how do we even start looking for technosignatures in other galaxies?
Well, one promising approach is to search for what we call anomalous spectral signatures.
In English phrase.
Basically, we're looking for weird stuff in the light coming from a galaxy. Stuff that could point to large-scale structures or crazy energy sources that wouldn't be there naturally.
Wait, are we talking about like Dyson spheres around stars and other galaxies?
That's one possibility. Or imagine a civilization that's figured out how to use the energy of a whole galaxy. They might leave a detectable fingerprint on the light coming from that galaxy.
Wow, okay, that's mind-blowing. So instead of looking for tiny planets, we're looking for signs of civilizations that have basically taken over entire galaxies.
Exactly. It's a whole different scale of thinking.
Okay, I'm sold on the idea, but realistically, how likely are we to actually find something?
It's tough to say. The odds are definitely long, but there are billions of galaxies out there. Even if just a tiny fraction of them have civilizations that can manipulate energy on a galactic scale, we might be able to pick up on it.
So it's a long shot, but a long shot with a potentially huge payoff.
Exactly. And even if we don't have the tech to do these searches effectively right now,
Yeah.
it's something future scientists will definitely be exploring.
It's amazing to think about. Extragalactic SETI, it really highlights just how vast the universe is and how much is still out there to discover.
It does, doesn't it?
Yeah.
Makes you wonder what else we might find out there.
Okay, so we've talked about better telescopes, smarter algorithms, even going beyond our own galaxy. But is there anything we can do here on Earth to boost our chances of finding ET?
There is. And it involves looking inward at our understanding of life itself.
So it's not just about looking outward, it's about looking inward too.
Precisely. Right now, we're mostly looking for life that's similar to what we know here on Earth. But what if alien life is totally different?
Right, we could be missing signals because we're not even looking for the right things.
Exactly. That's why it's so important to push our understanding of astrobiology even further.
So more research into how life could arise in extreme environments. Studying those weird extremophiles here on Earth to see how tough life can be.
Exactly. The more we understand about how diverse and resilient life is here on Earth, the better we'll be at imagining and finding life that's totally different.
I like that. Life as we don't know it. It really opens up the possibilities.
It does, doesn't it? We have to break free from our Earth-centric biases and consider things that might seem crazy at first.
Like silicon-based life forms, or creatures that live in what we'd consider toxic environments.
Exactly. Or even intelligence that doesn't use technology the way we do.
Whoa, my mind is officially blown. Now I'm picturing, like, a civilization of sentient clouds.
Hey, who knows? Anything's possible.
Yeah.
The point is, we need to expand our imagination as much as our technology if we want to recognize alien life when we find it.
This is getting pretty deep. It's like the search for aliens is also a search for ourselves, a way to figure out what it means to be alive and conscious in this crazy universe.
Beautifully put. It's a search that challenges our assumptions, expands our knowledge, and forces us to face the big questions.
And maybe, just maybe, the answers to those questions are out there somewhere?
I have a feeling they are.
Well, that's a thought to ponder. We've covered a lot of ground today, from the depths of Earth's history to the farthest reaches of space, all trying to figure out if we're alone in the universe.
And even if we don't have a definitive answer yet, The search itself has been incredibly rewarding.
It has. It's made us rethink our assumptions, use our imaginations, and appreciate the incredible diversity of the universe.
And at the end of the day, whether we find other civilizations or not, the journey of exploration and discovery is what matters.
Couldn't agree more. So I think it's time to wrap up this part of our deep dive. But don't go anywhere. We'll be back soon to explore some of the even deeper philosophical and ethical implications of the Fermi Paradox and what it might mean for our future as a species. All right, so we've covered a lot of ground in this deep dive. We've talked about the science behind the Fermi Paradox, all those different explanations for why we haven't found aliens yet.
And we've looked at some of the ways we might be able to find them, or at least evidence of their technology.
Technosignatures, right, Dyson spheres, pollution, all that cool stuff.
Exactly. But there's one big question that kind of looms over all of this, and it's kind of scary to think about.
What if we really are alone?
That's the one.
Gotcha.
What if, despite all those billions and billions of stars and planets out there, intelligent life like ours is super rare?
It's a lonely thought, isn't it? For a long time, I think a lot of people took comfort in the idea that the universe was teeming with life, that we were part of something bigger. But now, the more we learn, the more it seems like we might be the exception, not the rule.
It's definitely a humbling thought, and it makes you rethink our place in the universe and our responsibility to life here on Earth.
Yeah, if we're the only ones who can appreciate the beauty and complexity of the cosmos, does that mean we have a special obligation to protect it? To make sure consciousness doesn't just disappear?
That's one way to look at it for sure, kind of cosmic imperative. But it's not the only way. Some people might find it liberating, even empowering.
How so?
Well, if we really are unique, then every discovery we make, every act of creation, every step we take toward understanding the universe becomes even more meaningful.
I can see that. It's like we become the protagonists in the story of the universe, with the potential to shape the future of intelligence itself.
Exactly. And it highlights the importance of curiosity, of exploration, of pushing the boundaries of knowledge. Whether we find aliens or not, the pursuit of that knowledge is what makes us human.
Beautifully said. This whole conversation has really made me think about the Fermi Paradox differently. It's not just a science problem to solve. It's a reflection of our deepest hopes and fears, our desire for connection, and our fascination with the unknown.
It's a reminder that even in the vastness of space, the questions we ask, the meaning we find, it's all ultimately about us, about being human.
Well said. And on that note, I think we've reached the end of our deep dive into the Fermi Paradox.
It's been an amazing journey. We've explored the science, the possibilities, and the philosophical implications of this fascinating history.
We may not have all the answers, but we've definitely gained a deeper understanding of the question and of the incredible efforts being made to find those answers.
And who knows, maybe someday, whether through new discoveries or just plain luck, we'll finally break through the silence and find out that we're not alone after all.
That's a great thought to end on. Thanks for joining us on this exploration of the Fermi Paradox, everyone. And until next time, keep looking up at the stars and keep wondering about the mysteries of the universe.